Morning, everybody. I remain Olusegun Timothy. Today we'll be looking at proofs of laws. Proofs of laws of logarithm, and these are the laws of logarithm I want to prove today. And if you'd watched my last video, I proved this one, but I'm still going to do it again today. So starting from there, we move. So I'll say 1, I'll say log AXY equal to log AX plus log AY. Now remember the law of logarithm. Remember how we define logarithm? That if you have log base 10 to 1000, this will give you what 3, meaning that when you take 10 to the power 3, you get back your 1000. That is what we're going to do today. That's what we're going to do to this one. So now I'm going to say this is the base, here is the base, 10 to the power a to the power of all this in brackets. So a in brackets log ax plus log ay to give us what? X, y. I can now say let my log a x be equal to m log ay equal to what? N. I will now have a raised to the power m plus n to be equal to what? Xy. And remember, in indices, when you have this kind of thing, you know that there are some multiplications that went on. They have the same base but different powers, just like a raised to the power m multiplied by a raised to the power n. This will give us a raised to the power m plus n. That is what we're going to do here. So now I'm going to separate them. I'll now have a raised to the power m multiplied by a raised to the power n to give me what? X, y. Now I might now say let my a raised to the power m be equal to what? X, and a raised to the power n equal to y. And now here is a raised to the power m equal to x, and now x multiplied by y equal to what? Xy, which implies that xy is equal to xy. Or I can also say, or a raised to the power m to be equal to y, and a raised to the power n to be equal to what? X. This will still give me y times x is equal to what? Xy, which implies that what? Yx is equal to what? Xy. So they are the same thing. We can call this method 1. We can call this the first method. So there's another way I did this. The other one says the log of axy is equal to log of ax plus log of ay. Now, using that same log, 10, 1000 equal to 3, 10, 3 equal to 1000. I'm going to do it to everything here. So I now have, I say let log axy equal to what? Z log ax equal to m log ay equal to n. I now have that a raised to the power z is equal to what? Xy. A raised to the power m is equal to what? X. A raised to the power n, a to the power n is equal to what? Y. So now I'll use this one and substitute this x and y in this equation. So now that a raised to the power z is equal to what is my x? A raised to the power m times what is my y? A raised to the power n. What did I succeed in doing? I succeeded in putting all of them in the same what? Base. So now what I have here now, this will now give me that a raised to the power z is equal to what? A. Indices, I will add the powers m plus n. So I now have that a raised to the power z is equal to a raised to the power m plus n. Now this implies that since they have the same base, I can be able to what? Equate the powers. Z is equal to what? M plus n. What is my z? My z is log axy is equal to what is my m? Log ax. What is my y? My n plus log ay. So you see now, you can call this method 2. It's the same thing. So that is how I proved number 1. And the next one, number 2, says the log of b is equal to what? 1. The log of a number to the base of that same number is equal to what? 1. But there are some exclusions. So what are the exclusions? This b here, this b, the base must be greater than what? 0, and the b must not be equal to 1. Maybe in my next video I will tell you why, and we are going to see why. But we want to prove this now. We want to use this method, this way of logarithm definition, to do this. You see, b raised to the power 1 is equal to what? B. And this is very simple and easier. With the knowledge of mathematics, I will have that anything raised to the power 1 will give us that number back. If it is now my name, Chukwuebuka raised to the power 1 will still give me back what? Chukwuebuka, nothing more. So that is what we're going. That is what we applied here. So b raised to the power 1 gives us b. That is the answer. That is how we prove it. But there's another thing I want to show you now. In programming, this equality sign here is called what? Assignment. So log b base b has been assigned the number 1. Now I have log b base b is equal to what? 1. I want to put a common base. I want to take them to a common what? Base. Let me just say I use base a. I say base a to the power log b equals to base a1. Anything you do to the left hand side, you do to the right hand side. Now you see from here, now this is equal to this. So here I will not be bothered about any other thing. I will just put 1 here because 1 has been assigned to this log bb. So I have a raised to the power 1 is equal to a raised to the power 1. So this implies that a is equal to what? A. Now see, coming from this other side, we also prove that a is equal to a, that log bb is equal to what? 1. So you see that it's should I say simple. This one is the easier one. So now the next one, the third part is number 3, says if log by is equal to 1, then y is equal to what? B. Using this same pattern again, log b y is equal to what? 1. But y is what? Unknown. We don't so we want to look for what? Y. We want to look for y. So now, using that method, 10 raised to the power 1, b raised to the power 1 is equal to what? That's what we don't know. But remember, from knowledge of mathematics, that anything raised to the power 1 is that same number. It will be easier for us to know that b raised to the power 1 is b. So therefore, in this one now, log by is equal to what? 1, which implies that b is equal to what? Which implies that y is equal to b. So that is how to prove this one. This one is not so hard. So let's go over to number 4. Number 4 says log b1 is equal to what? 0. And remember, this b must be greater than 0 and b must not be equal to 1. So using this pattern of definition of log, you can say log okay, we'll say b raised to the power 0 is equal to what? 1. And with knowledge of mathematics that we have, that anything raised to the power 0 is 1, it is easier for us to see and to understand that b raised to the power 0 is 1, meaning that log of 1 to the base, log of 1 to any base is what? 0. Because when you take the power of 0 to any number, you get backwards 1. So now let us take this assignment, should I call it operation in programming. Log 1 base b has been assigned the number what? 0. Let us take a common base. Log 1b is equal to what? 0. Let us take a common base. Let's say base a. A to the power log 1 base b is equal to a to the power 0. What is log 1 base b? Log 1 base b is 0. So a raised to the power 0 is equal to a raised to the power 0. Meaning that what? 1 is equal to 1. Do you see? So go back to number 5. Go back to number 5. Number 5 says if log bx is equal to 0, then x is equal to 1. Using this definition again, we say b raised to the power 0. B raised to the power 0 is what? We don't know, because this x is an unknown, this x is an unknown. But with knowledge of mathematics, that we have that anything raised to the power 0 is 1. What is b raised to the power 0? B raised to the power 0 is simply what? 1. B raised to the power 0 is simply 1. This implies that b raised to the power 0 is equal to what? X is equal to 1. So simply x is equal to 1. And this is what they told us from the question they gave us to prove. If log x base b is equal to 0, then x is equal to 1. And with that, we come to the end of today's proof. Please, I plead and I plead. If there's any mistake, if there's anywhere you find a mistake, you can correct it in the comment box below. And also, give me a thumbs up if I did what is necessary. Thank you. I remain Timothy.